Hello Titans, it's Mr. Spilker here, and I'm going to take you through Chapter 6, Section 5, Part 2. And Part 2 of Chapter 6, Section 5 is focusing on solving absolute value inequalities. So if you can recall, back in Part 1, we solved absolute value equations. Now here in Part 2, we're going to solve absolute value inequalities. Alright, let's jump right into this. Anytime you have an absolute value inequality with the less than sign, we want you to think that that's an and problem. Less than is an and problem. And if you have a greater than, that is an or problem. Absolute value equations had two solutions. Just like absolute value equations have two solutions, absolute value inequalities also have two solutions. So these absolute value inequalities, when we solve them, are going to look very familiar to you because they are solved and the answer comes out to be very similar to compound inequalities. So absolute value inequalities and compound inequalities, which we studied earlier in this chapter in 6.3, are very similar. When solving an absolute value inequality, you want to first of all rewrite the inequality as a conjunction or disjunction. Let's simplify that for you. If you have a less than or less than or equal to, then you are working with what we call a conjunction, or in other words, what you know it as an and statement. So students, it's very important for you to remember less than. Anytime you have a less than sign, I want you to think less than and type. If you have a greater than sign or a greater than or equal to, you are working with a disjunction, or in other words, you know this as an or statement. So think greater, greater. The second step is then to go ahead and write your two inequalities. The first inequality is going to be the same, just without the bars. The second inequality, you must negate the right-hand side, in other words, make it negative, and flip or reverse the direction of the inequality sign. Then you have your two inequalities, and you solve it just as you would a compound inequality. So step 1, rewrite it as an and or an or. And then step 2, go ahead and write your two inequalities. And then your last thing to do is just solve it as a compound inequality. I think you will better understand this process when we get into some examples. So let's go ahead and do that. Alright, here is example number 1. Now in example number 1, as you can tell, we have a greater sign. So since it's a greater than sign, remember we want to think greater. I know I spelled that wrong. I did it on purpose. Greater. When you see a greater than sign, I want you to think greater. So since it's greater than sign, notice we wrote the word or there. Greater, or. Now I'm going to write my two inequalities. My first inequality is the same, just without the bars. The first inequality is the same, just without the bars. The first inequality is the same, just without the bars. The second inequality is the same as the first, except you make two changes. You flip the inequality symbol, and you make the number that's by itself, that 7, become negative. So you make two changes. Flip the inequality, make the isolated number negative. You make two changes. Flip the inequality symbol, make the number that's isolated negative. Then you solve. So you subtract 1 from each side and divide by 2, and your first answer is greater than 3. And then the second one, you go ahead and subtract 1, divide by 2, and you get x is less than negative 4. So you graph those both with open circles, and you shade to the right of 3, and you shade to the left of negative 4. So that's your answer. That's example number 1. Hopefully you have that down in your notes. If not, pause it and go ahead and make sure you get that down into your notes. Alright students, here's example number 2. Example number 2, we have a less than sign. So when you see less than, I want you to think less than and. So as you can tell, the first thing I'm going to do is put it as an and statement. The first inequality is the same, just without the bars. The second inequality, I make two changes. I go ahead and I flip my inequality, and I change the 3 to be a negative. Then I solve my two inequalities. I get an answer of x is less than 8, so open circle on 8, shade to the left, open circle on 2, shade to the right, so my shading is between. So as you can see, I have solved example number 2. Once again, put it in your notes. So if you don't have this in your notes, pause it and get it down. Alright, a couple more additional examples here to finish up our teaching lesson. Solve and graph 4x minus 9 is less than or equal to 21. Now when I look at this problem, I first of all see a less than sign, so I'm going to think less than. So I'm going to go ahead and write it as an and type. You can either write it in this format, or I guess the way I prefer to do it is to go ahead and write out the two inequalities. 4x minus 9 is less than or equal to 21. So the same, just without the bars. That's the first one. And then the second one is going to be 4x minus 9. I'm going to make two changes. I'm going to flip my inequality and change 21 to be negative. Now I solve those two inequalities, and then I graph them accordingly. And as you can see, my answers come out to be negative 3 and 7.5. The last teaching point we need to make in this video is that you must have the absolute value by itself first. So if you ever run into a problem where the absolute value is not isolated, the very first thing you need to do is then go ahead and isolate it. So in this problem, the very first thing I would do is take away 3 from each side. Then that leaves me with the absolute value of 3x minus 2 is greater than or equal to 8. So it's a greater problem. So I'm going to go ahead and put it as an or statement. First inequality, the same, just without the bars. Second inequality, I make the two changes that are needed. Then I go ahead and solve. We're going to go ahead and finish up this video tonight by just reminding you of the special cases. Special cases do exist with absolute value inequalities. Just remember that when you have the or type of a compound inequality, that it should graph like oars on a boat, opposite. If it does not, then the answer is all reals. And just remember that when you have the and type of a compound inequality, and should graph between. If it does not, if it graphs as an or, then there is no solution. So just like we had those special cases with compound inequalities, we do have those special cases here with absolute value inequalities also. So make sure you keep that in mind when solving these. So just a reminder here of the or type and the and type. If you don't have this down in your notes already, this would be a good time to add it. So that concludes our teaching lesson for tonight, Titans. Hopefully you enjoyed Chapter 6, Section 5, Part 2. Hopefully you have some notes down over it. Come to class prepared to practice this, and if you have any questions, please enter them below on the Google form. It's great to fill out those Google forms. It helps us adjust our teaching for the next class period. So please get that Google form filled out. It takes about 2 minutes. Thanks for listening tonight, Titans. Stay classy.